Hi class, it's Bill Berry here. We're in week 5 and we are in our Java 2 course, of course, and we are looking first at statics today. We have used statics, you have used statics no doubt, to create constants, and you've probably understood a little bit about the basics of what they are and how they work, but maybe we haven't really explored them as deeply as we should, so we're going to start with a talk about statics. And the other things that are coming in the rest of this week are also cool things, so stay tuned for those, but let's focus on statics for now. First thing that we want to look at here, hello pointer. First thing we want to look at here is the idea of the two different worlds, the static world and the instance world. We have to really be clear about how these two things are, what they are, and why the visibility from one world into the other is so different. The analogy that I'll provide here is that of a one-way mirror. We have instance things, we'll talk about various things, data, methods, etc., and we have static things. Static things are per class, as we've seen, and we will see more, whereas instance things are per object. The thing that we need to get clear, think about this as a one-way mirror. If you look from the instance world, you have visibility into the static world with no problem whatsoever, because statics are members of the class, and therefore since objects are created from that class, they have no problem peering into the static world and looking at data using methods, etc., right? There is no problem with that because objects can always see the things that pertain to their class. But the reverse here is not true. The one-way mirror, you can see through it this way, you cannot see through it this way. The static world cannot peer into the instance world. Why? Because statics are per class and they have no idea that the instance world even exists, right? They have no way to know that instances were ever created and what they are and what they contain. Another analogy would be static is kind of the fact that humans have eyes, right? That's not a surprising fact. Humans have eyes, and so that is sort of a static property of the human race. But when you want to talk about somebody's specific eye color, that doesn't make any sense in the static world, right? The fact that there is an eye color, great, but if you want to talk about a specific person's irises and exactly what kind of colors are in those irises, that doesn't make sense to the static world, right? They don't have any way to know about a specific person because that's not what they're about. They're about per class. Human race has eyes, great. A particular person has a particular color of irises, right? That's a different matter and it's a different world. So we want to think about this fact and be clear about the fact, because you're going to see this when you try to misuse these things. When you try to compile and run, you're going to see this thing that says you can't use instance data from a static context. So you're going to see this. Remember this one-way mirror analogy. Maybe that'll help as we go along. All right, so first let's talk about variables and constants. All right, so there's going to be, we're going to use these things a lot, and remember that statics in all contexts, why is my computer acting so laggy? Statics are common to all objects. That means that you have only one copy of the variable or constant. For all the instances in your computer, you have one. So they're very memory efficient because for one whole class, you get one particular memory allocation for all of the objects. That's great. Memory is allocated one time. The other interesting thing is that's at the time of class loading, right? The memory is allocated at the time of class load. Now, interestingly, we may not have really understood and looked into what it even means to have class loading. Oops. So let's take a peek at that and make sure that we're clear on what causes this kind of load to happen. So if we look here at a simple example, I have this static block demo class created and I have a main created to work with it. We're going to get into more depth here, but let's first look at the fact that in this particular demo, all I'm doing is doing a print, right? I'm just doing a println to say, hey, we're in main, and we're going to get more interesting here in a minute. But let's say that we just declare a reference of that type. right? If I declare just a reference of that type, now I've got some code in that other class that's going to print when this is loaded, right? When the class is loaded, it's going to cause a print to happen. We're going to look at that code in a minute. That's unimportant. Just remember, it's going to announce itself as having been loaded. Now, in this case, all I'm doing is declaring a reference, and that is not going to trigger class load. If I run my main, even though, notice there's the arrow, right? There's a has-a relationship there. When I run main, it's going to say, hey, there's no note that anything happened over in that other class. So this did not trigger a class load just because we created a reference to an object of that type. The only thing that's going to make it actually load the class is if that class is actually used in an instantiation. So in this case, I'll recompile, and notice now I'm assigning that. So the static type, again, static here is sort of different. Static and dynamic types of bindings are sort of a different use of the term, but the type of the reference is this. But now it's actually instantiating one of these things. So what happens now when I run this? Well, now I get the message that something was going on, right? Something else is going on in the class. And again, we'll come back to that. But I just wanted to point out that class load is something that maybe we haven't thought about. The fact that when a class is used for an instantiation, the project knows about it, Java knows about it, and it knows it has to load up that class, right? So memory allocation for statics is done then. Of course, if something's marked final, it becomes a constant. We like constants. And again, as we would expect, you can access static and instance methods, right? From static and instance methods, you can access static data, right? Of course, remember the reverse is not true based on our one-way mirror idea, right? So if you want to access your static variables and constants, great, access them from wherever you like. So why would we use these? Well, we've used constants a lot, right? We like constants, statics, right? We've used them. Why would you use a static variable? Well, maybe you're going to have a counter, right? You want to create how many objects have been instantiated. Maybe you want to generate an ID, right? You want to automatically generate the next ID available in the system. Interesting thing is, of course, how do you then save that? How do you persist it so that next time you start you use the same one? Interesting topic, and we're going to get into some things that might be useful in that regard. So static variables and constants, hopefully that makes sense based on our understanding now of static and instance world views. What about methods? Well, a static method, again, belongs to the class. So you can invoke it directly from the class. You don't need an instance to do that, right? And of course, a static method can manipulate static data, but it cannot access instance data. Again, from the concept of the fact that humans have eyes, that concept does not allow you to talk about a particular human's eyes. That's an instance, that's an object, right? So instance data cannot look through the one-way mirror. So one of the things that should be clear, if you can think about it, the keyword this doesn't make sense at all. If you're writing a static method, you better not try to use this, and you better not try to use super. Remember that this stuff exists completely outside the inheritance hierarchy. The static world doesn't even know that the instance world exists. It does not know that the whole hierarchy business and inheritance, that's a completely foreign concept to statics because they just don't exist that way, right? They exist on a different plane. Now, one other thing that's kind of interesting about those is that static methods are considered pure functions. When you call a static method, you are literally telling it to go run code at a particular memory address. Because remember, when we talk about instance methods, we are getting into polymorphism, we're getting into dynamic dispatch, which means there's going to be a lookup table every time you want to call a method that's an instance method, which is everything that's not marked as a static. Java has to go look it up in the table to figure out which one to run polymorphically. So these static methods are considered pure functions because they don't have to participate in that silliness, right? So they're always going to be faster, and of course they can't be overridden because again they don't participate in that world, right? They don't have any view into the inheritance world. So you can't override a static because overriding is a polymorphic, right? It is an instance kind of idea. So static methods, different thing, right? We got to think about our static methods and what can be. In fact, we'd want to use static methods when possible, right? Why would we use an instance when a static would do? In fact, some IDEs, if you are compiling in Eclipse or maybe something else that's fancy, you will see that it might recommend, it looks at some of your methods and says, you know what, you're not using any static data here. I bet you could make this a static method, which was probably a good pointer, right? Probably a good idea. Our particular IDE doesn't do that, but you certainly can take that advice if you have it offered to you. That's great. Now here's one thing you've probably never seen before. This is a cool one, and that is static inner classes. We know that, and we've seen that in different circumstances. Let me bring up something that will illustrate this. In different circumstances, like when we are working with a linked list, you have seen that very often we have an inner class here, right? When we define our nodes, you'll notice that we define them inside the linked list class. Why? Well, in this case, we don't really need anybody else to know our business, right? The way that we're implementing things is not anybody else's business. So we've even made this private here because we're only using it inside the linked list class, and we're not having anybody in the outside talk to us in nodes. They are only speaking to us in data. Well, that's great. The only thing that can happen here, sometimes it's good, sometimes it's not. The thing that happens here is you could make use of the outer classes, the enclosing classes data down in here. You could, if you wanted, actually access the front, reference or something like that. Now, sometimes that's what you want, and sometimes that's not what you want. Like in this case, nodes really have no business. Encapsulation says nodes have no business knowing about the list in which they live, right? There's no reason for them to. They are strictly a building block. So one of the cool things that you can do is you can simply mark these static, right? If you mark this static, there's a couple of interesting things that happen, but the main one that we want to talk about now is you can't access the outer classes stuff because that is instance stuff, and now you're working in a class that's marked static. There's really only two things that happen, and this is the main one to note, right, is that it keeps you from messing with the enclosing classes data, which in this case is good. If we used it anywhere here, that's probably not a good thing, right? We probably want to stay on the straight and narrow and not mess with the list stuff. So that's a clever use for the static keyword that you've probably never seen, right? So cool stuff about that. And notice everything else works great. You can still instantiate it. You can still do everything that you need to do. It doesn't change any of the way that the list works. It just keeps us from messing with stuff that probably we don't want to mess with anyway. So that's a cool use of static, right? And if we run this, we'd see it works perfectly fine. Now, the other thing that happens is if you have an inner class that's not marked static, there is a very strange syntax that you have to use. With an inner class that is instance, of course you have to have an instance of the outer class, the enclosing class, before you create an instance of the inner class. So there's this bizarre syntax. If our nodes, for instance, had been public instead of private, I would have to create the outer class first, like link list dot new, and then I put the name of the inner class to create a node. So if it were public and it were internal like this, you have this bizarre syntax that you would probably never think of, right? Literally link list dot new, and then you put the node. So that is bizarre. But if you make it static, then you don't have to do that, right? So if it were public, you could just declare it like you would normally do it, right? So you don't have to have an instance of that to do it. You can just use the class name and then make the inner class. So that is another benefit of marking something static if you need to use it as public instead of private. So that's now something new about static that you've probably never seen before, right? So two things you have probably looked at, and that is static data and constants and static methods, but certainly this is a new thing. About to show you another new thing that is super interesting, I think, and that is a static block. We are used to using constructors to initialize variables, right? We're used to that. But what if you have a static and you want to initialize that? Where would you do that? So let me show you an example of something we probably might think to do, and then let's talk about the downsides. So let's say here that in our static block demo class, we're going to come to the block part in a minute, but let's say that in this class we have a static variable, in this case it's called bar, and then in the constructor where we normally think to put our assignments, right, when we want to initialize variables, we often do these in the constructor. Well, does that make sense for a static? Well, kind of no, right? Kind of no, because we are setting bar to 1 for every single item that we instantiate. If we're creating nodes, if we're creating hundreds and hundreds of or thousands of items, every single time we're setting that to 1 again and again and again, thousands of times potentially. That's kind of stupid, right? That's kind of wasted code. So maybe we wouldn't want to do that there. So you might say, well, I'm clever enough, I can certainly do that here, which is great, right? That's fine. Now, there's no particular downside to that, except typically we don't make assignments in there. A lot of times in a lot of corporate style guides you might see that they don't do their initializations out there because they always want to put them in constructors because that's a one-stop shopping, right? Well, that doesn't make sense for a static, we've just said. So you could certainly do it up here, and then it would be done when? When would it make that assignment? At class load time, of course, right? That's when it would work. Well, that's perfectly fine. But one downside here is that in here you can write code, right? I can write code here. So what if I were declaring a static as maybe an array? What if I were creating an array of these things and I wanted to go initialize them and I wanted to use a loop, right? Maybe I want something other than the Java provided defaults and I want to write some code. You can't write code in global space like this, right? You can make assignments, but I can't write code. So that I could have done down here, but then we know again that would be inefficient. So what is the option? What is my option here? Well, we're going to look at something that is eye-opening and kind of amazing, and it's called a static block, and it looks something like this. You can, right out of thin air, this was amazing to me when I saw it, you can write the word static and then you can write a block of code. Right now, I hope you know that in Java you can just write code like this, right? You can open and close curly braces out of thin air and you can write code like this, and the benefit of doing that is that you get scoping, right? There is block scope, and if you create variables in this space, they will be deleted, right? They'll be garbage collected when you hit the close curly brace. Well, that's great. But what if you write the word static in front of it? If you write the word static in front of it, you are creating code that is going to be run at class load time. Think about that. This is not going to be run at instantiation of an item. This is going to be run at class load time. So this is going to run before anything else in this system, right? Anything else that happens even in main, right? This is going to run first. And the nice thing is you can not only assign static data to values, of course, you can write code that would loop through an array and assign values. You can do whatever you need to do because this is a place to write code. And notice it's not in a method. It's just sitting out in the ether here in global space called static. And you can have more than one of these blocks of code. They're going to be run in order. I don't know why you'd have more, but you could. So you can write a static block of code, right? To me, this was a little mind-blowing and super cool. Again, why would you do it? If all you were going to do is do this, would you really write that static block? I don't know. But certainly if you need to write some code to go along with it, this is super cool. And of course, now when we compile and run that, watch what happens. Okay, oops, let me clear this because otherwise it's a little confusing. So let me run it again. Here we go. So notice you get this code running before main even has to run because Java is loading up those classes that are used and it's running that static code block. So it says, hey, bar used to be 1 but or 0, but I've now set it to 1, and then we get the announcement that we're in main. So the static block ran first at class load time before main even got a chance. So to me, that is a cool concept, right? It is a super cool concept. So you're gonna, here's the details. I've said all of this stuff that's here, I believe, but that is just an interesting thing about statics. So I hope that we've learned some things about static that have really expanded your understanding, right? We've talked about variables and constants, maybe you knew it. We've talked about methods, maybe you knew it. Bet you didn't know about using static blocks, and probably, you know, maybe you didn't know about marking inner classes static and what the benefits of those were. So I'm going to give you some reference materials here. I think that there are some interesting discussions that you might want to follow up on. So you might want to pause the slide here. I'm sorry if you're only watching online. I know that's some typing to do, but there are some good links here that if you want to follow up and discuss a little more, see in a little more depth, these things will help you. So thanks for watching this video. Again, I hope you see that I find these topics fascinating, and I hope that you do as well. Thanks for watching the video, and we'll continue on with design patterns and jumping into a sample one just to kind of whet our appetite about design patterns, and there's so much more interesting material coming in this course. So again, thanks for watching.